way we rise above that human response is education. And it takes a very brave person to push past their fear by education, because automation isn't scary if you begin to understand what it's doing.
Welcome to this week's MTD Podcast, evolving into the future of manufacturing with ZEISS. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a very proud member of the MTD team. It's an absolute pleasure to be rejoined by a very special guest today, an advocate for metrology and manufacturing. We have the pleasure to be joined again by Jay Alapano from Germany, aka the Measuring Hero, with a list of qualifications that include a BS in mechanical engineering and an MBA focusing on international business. Jay's current role is the product manager at ZEISS IQS, and he's recently been on a 2-year assignment in Germany for the launch of a new optical metrology product, which we'll be talking all about today. Welcome, Jay.
Gio, thank you for having me again. It's always a pleasure to speak to you. So thank you from the bottom of my heart for welcoming me.
No, thank you, Jay. Your hashtag Measuring Hero videos are absolutely fabulous. For our listeners that haven't seen them yet, please check them out on YouTube. Jay, thanks so much again for joining us today. I know you're in Germany. How have you been recently?
Everything's great over here. We are. I'm enjoying the warm confines of my flat here as we are kind of buckled down for the winter. I actually just got back from the United States, so I'm in the midst of a quarantine here. But everything's fine. Enjoying the fall, crisp weather, and preparing for winter time.
It's been a crazy year. For sure, Jay, and hopefully, things will start getting back to some kind of normality at some point soon. Now, for our listeners, Carl ZEISS are a massive organisation globally. Most listeners will be familiar with the lenses and cameras. However, today we will be concentrating on the metrology side of the business. Jay, can you give our listeners, to start off with, a brief insight into ZEISS and the metrology solutions that you offer?
Absolutely. ZEISS started, over 170 years ago with the creation of the microscope. The portfolio twist and turned from there. But about 100 years ago, then we began our actual metrology group. We created a thread screw gauge about 100 years ago. And from there, we began doing different measurement equipment, multifaceted thread gauges and things like that. Then we began to really excel in tactile measurement equipment, and were some of the original pioneers to the coordinate measuring machine, the tactile coordinate measuring machine. So from there, the the industrial metrology portfolio grew from there. It touches many different things now. So if you add now the metrology plus the microscopy groups together, we comprise about a quarter of ZEISS's entire portfolio. So we have, of course, expanded beyond coordinate measuring machines to optical measuring machines, full CT scanners, portable metrology. Oh my gosh, countless. The industrial metrology portfolio has gotten quite big. So yeah, that's about us and our portion of ZEISS.
Wow, it's a vast portfolio of solutions, and you're continuously evolving too, and you're evolving very quickly, may I add. Now, Jay, let's refresh our memories. From our last question time live, this was the last time we spoke together. We did it with David Shute, who unfortunately couldn't join us today. But this was during the first lockdown. We discussed evolving technologies and new products from ZEISS, and we also touched upon a product that we couldn't go into too much detail about at that time. Now, Jay, take it away and tell us all about the launch of the all-new ODetect.
Absolutely, Gio. Thank you again. Yeah, when we spoke last time, I teased with you that I came to launch a product, and at the time we couldn't talk about it because we hadn't released it yet. We just released the ODetect on October 20th, and it is the product that I was actually originally brought to Germany to launch. We have been working on the ODetect, which is a new product in our optical metrology portfolio. We've been working on this, Geo, for about 4 or 5 years now. And yeah, it serves as a optical measuring solution that is more geared towards a different type of persona, a different person than would typically use our OInspect, which was our what I'll call larger brother to the portfolio. This persona is meant to be for a user that is maybe new to metrology, or maybe not a full-time metrologist. For example, it could be someone that is in incoming inspection, or someone that works on the production floor and is a full CNC machinist but needs to measure their own. We've designed the ODetect and the subsequent software Sapphire to be approachable for those people. So it really kind of exemplifies from a hardware and software standpoint, easy to use, easy to approach, easy to learn, and good quality measurements. Like I said, yeah, we couldn't talk about it before, but we've had a whole ton of advancements around the hardware and software. Yeah, and you can imagine there was a veil over it. I couldn't talk about the software. I couldn't talk about because yeah, we were months away, but here it is now.
No, brilliant, Jay. And there's going to be videos coming out soon on the new ODetect. I'm sure on ZEISS platforms, but also on the MTD CNC platforms too. Now, Jay, would it be safe to say then that this product is evolved because you're trying to find a solution that simplifies the way in which you inspect components?
That is exactly it. You know, what we've learned when we're looking at megatrends, this is kind of what we were talking about last time, is that in today's age, one of the megatrends that we've seen in the world today, especially when it comes to usability, is things have to be easier to use. Things have to be more approachable. The days of overly complicated solutions, I think, are over. You know, we have to be able to not just access our data, but we need to generate it as quickly as possible with the least amount of training. And based on that insight, years and years ago, we set out to make a very, very easy to use platform. So we also realized that hardware and software could not operate in a vacuum. We could not just make easy to use software or easy to use hardware solutions. We really had to put a project together that married the two and blur the lines between the two. So exactly as you say, Gio, this product bore from a real desire to make a very approachable metrology solution that encompassed both hardware and software.
Well, I think that you've achieved that, Jay. So congratulations. And for our audience that don't know, I believe you were heavily involved in the design of this new product.
Yeah. Well, I don't want to take a ton of credit for it because it actually it started well before me. When I was still in the United States, we actually began the hardware component of this as a next generation optics engine platform. And then as we kind of got that, they elicited my input from the United States, and then and as well as colleagues from China, India, all over EMEA. And then as it kind of culminated at the end and it looked like we needed to cross the goal line, that's when they brought me in, and with more of a sales and marketing hat, I brought it across. But we, especially towards the end there, we really, I was really part of the team that kind of decided what functionality would come when we would do it. But I don't want to take credit for the team effort. The team worked very hard before me, and they will continue to work hard after I go back.
It's certainly a fantastic product. I've had the pleasure of seeing the product firsthand recently, actually, and as mentioned, there are going to be some fantastic videos on the product coming soon, so you'll get to, our audience, our listeners will get to see the product visually coming soon on MTD CNC. Now, in my opinion, Jay, all the best designs in the world, from the Egyptian time, are the simplest designs, and simplicity is key. And I completely get where you're coming from with that. So let's explain to our audience, how simple is it to inspect a part? So I've got a component, I need to inspect it. What do they need to do?
It's a great question, and it's a multifaceted answer. Gio, the answer to your simple question about measuring a simple part is complicated. But isn't that always the way? Because like I said, on our customers' behalf, we made a lot of decisions for them to simplify their experience, right? The first thing that we did, if you want to, for example, a customer wants to belly up to a machine, put a small part down, and measure high resolution details quickly, right? It sounds very easy. A user might put a part down, and then make a few clicks, get a report, and go. As a matter of fact, I put out a training that will teach a user to make a simple measurement like that, and that training is about 15 minutes long. Now, let's unspool that for a second and talk about some of the things that ZEISS did to create that 15-minute experience for the customer. Was years worth of development. The first thing we did was, like I said, create this optical engine. This optical engine is a revolutionary digital zoom camera and lensing system. We used mechanical zooms. Now, the inclusion of a mechanical zoom might mean that the customer might, in order to make a simple measurement, might have to choose what magnification they choose to measure, 1x, 3x, 9x. Because we went to a full digital single magnification zoom, we have a large field of view at high resolution. We cut out the need, for the most part, for a customer to have to decide what magnification they need. So we've simplified the measurement by a hardware advancement. Because of this hardware advancement, the decision is made for them, right? They have the best of both worlds. They have high field of view, a big field of view, high resolution. So because we've improved our optics engine and we've simplified their experience, we have also, in addition to that, for example, simplified the user experience from a software standpoint. The navigation is very intuitive through our software. The system flow is the user, his or her eyes go from left to right, top to bottom. If they follow the flow of, you work from the menus from the left to the right, and each time you go each step from left to right, you open up a section that goes that has a list from top to bottom. So in order to make a measurement, they just follow instructions from left to right, top to bottom, and it will intuitively almost self-guide them through an inspection and a report. So we've completely blown up the structure of Calypso and made this new Sapphire software specifically for that user to easily, you don't have to necessarily know where things are, where they're hidden. You just follow left to right, top to bottom. So the user then, with very minimal training, can just know, hey, it's easy to measure this this part I have because I may not know what to do, but I just go left to right, top to bottom. The hardware has decided for me already what the best magnification is. We just go. The final thing that we did was actually, Gio, meshing of the two, which is little things like we've added a hardware camera, overview camera, and integrated it in this easy-to-use software. So what do I mean by that? The user used to have to go to the machine, grab a pair of joysticks, and navigate their way around this part with their hands on a joystick, their eyeballs looking at the part, and then periodically go back to the screen to look at the screen, see if they're there. We made a fully dedicated overview camera. All they have to do is stay in the software, eyes stay in the software, click, click, click. The main sensor moves, very minimal need to touch the joysticks. To further make it just an enjoyable, easy, the user doesn't really even have to know where the joysticks are. They just put it down and go. So little things like this to really, that's how easy it is. You just take a quick training, throw a part down, the software guides you, the hardware decides for itself the easiest things to use, and we've added tricks all over the place in the experience to be able to just go click, 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 get a report, and go. So yeah, sorry about the long-winded response to your simple question of how easy is it. It's a 15-minute training, and by all stretch of the imagination, to do caliper style measurements could take a couple minutes to get the results you need, full report, with the full knowledge that this is a ZEISS piece of equipment, ZEISS quality measurements that you would come to expect.
I mean, it sounds absolutely fantastic, Jay. I think that, I'm a big fan of Apple, and what you're telling me, I mean, Apple is very intuitive. I can remember my old smartphones and or mobile phones back then. Some of them that I've had in the past were very complicated to use, and they weren't very intuitive. It sounds to me like that you've merged the software with the hardware, and you've made it kind of conversational, but also an intuitive kind of conversational process. So even for someone that maybe is not a fully skilled metrologist, they could quite easily go on there and check parts accurately. Am I correct in saying that?
Absolutely, Gio. And as a matter of fact, the iPhone is a perfect example of the cues that we did. If you remember, back when the iPhone came, it couldn't do everything, but what it did do, it did extremely well. And then as it grew, it could do more and more things. And really, that's our intent when we started the ODetect. Right now, ODetect can't do everything, but what it can do, it does extremely well. And that's why, on the onset of this podcast, I was very explicit to say this is meant for a different customer set. It's meant for customers. It's not meant for the advanced customers right now. Right now, it's meant for a customer that doesn't need all of the really, really highly complex measurements. It needs good quality measurements fast, just like that original iPhone user. Apple took some core functionality of the smartphone experience and did it very, very, very well. And this is our cue from that. Today's iPhone looks completely different. Today's iPhone is as complex, can do as many, many complex things, but that's over the evolution of the iPhone. We aspire to do something similar with ODetect, but right now we are at its core foundation. I like to think we are iPhone Gen 1.
Absolutely, yeah.
We do what we do, which is what we designed it to do. We do very, very well, and we think that it will resonate extremely well with the customer that we designed it for, and that is, users that need metrology level measurement, but may not be full metrologists. You look at a CNC programmer. That's a really smart person. That person writes G code and understands 5-axis milling machines and all of the processes that it takes to make a part. That's a really, really smart person, but he or she is not a metrologist. So what we've designed the ODetect to be is a piece of equipment that a smart person, like a machinist, would be able to use, but that smart person, doesn't necessarily have to be a metrologist, and that's really what we're going for here.
Yeah, it makes complete sense, Jay. I mean, I get it 100%. I think that, in a day and age where the landscape of engineering is certainly changing at a faster rate than I could have possibly imagined. And I think that all the equipment and the technologies that are out there are there to aid a decreasing skill level in some ways. And I think that the skill, I don't say that in a negative way, but I think the skills are in different areas now for planning areas or strategical planning. And, the actual measurement, it needs to be simplified because of the day and age we live in. Time is a necessity. Now, Jay, for our listeners, before we move on to the next section of questions that I have for you, what kind of parts could they inspect with the ODetect, and what kind of accuracy could they inspect to?
Great question, and thanks for asking, Gio. The parts that we're primarily looking for, of course, the ODetect right now is in a 322 volume, so 300 millimeters by 200 millimeters by 200 millimeters. So the parts would you would really want to fit into that volume. We would, likely want to keep, parts within the the accuracy of the volume is 2.4 plus L over 150, I think. So somewhere in the 2.5 micron range would be where you want. Simply put, Geo, we think parts as small as little watch gears, something like that, up to bigger parts that will fit in the volume at the micron, 2.5 micron accuracy. I also loosely, not loosely, but I use the word the term 2.4 microns because that is full volumetric accuracy. So historically, a vision machine would only be accurate in X and Y, so only for flat parts, right? For us, if we limit ourselves to only X and Y, then we're 1.9 microns. But 2.4 microns is the full cube volume, which is, again, one of the selling points of the machine. We don't limit your part to a flat part, right? We give you a full volumetric accuracy, and we do it in a really novel way. to calibrate that. But so the parts that that our customers can to measure can be full 3D parts, right? They don't have to be flat parts because we will deliver an accuracy spec that is good for the whole cube. In the past, if you were a med device manufacturer in a highly regulated field like medical, you can now look at an ODetect quite brazenly and know that you're not don't need to worry about the accuracy of your machine. So I'm going to say that full 3D parts at high resolution at an accuracy of about 2.4 microns across the entire cube is something that is perfect for the ODetect.
It's just fantastic, Jay. I mean, I've never worked in the medical industry, but I've worked in the aerospace industry, and I never had to make components, within 2.4 microns. And I can tell you now, if I had the ODetect at that particular aerospace company that I worked for, it would have been a fantastic tool to have, and it would have saved a tremendous amount of time, 100%.
Yeah, it's crazy what we. I also now that you say that, Gio, I think back to my first few jobs as a metrologist, and I think, wow, if I had something like this, yeah, the flaming hoops I could have jumped through.
It's also the reporting side, isn't it? Before we again, I was going to move on to our next section, but can we just, before we move on to the next section, it's also the reporting side now, isn't it? You mentioned the medical industry. I've just mentioned the aerospace industry, and traceability nowadays is so high and so important. So can you just tell our audience, obviously, checking a part is one thing with your calipers and inspection equipment, but doesn't necessarily give you the right reporting, does it, Jay?
Traceability is multifaceted, absolutely. So, of course, we plug into PyWeb, which is the same infrastructure that we do across our entire portfolio. So whether it's OInspect or any of our CMMs or metrology, we can archive our data digitally via PyWeb. So digitization of your inspections are also a big megatrend in today's world. So that's another facet of traceability, is your digital ability to do digital archives. Another traceability factor for something like medical or aerospace is you need to calibrate your machines to a standard that go all the way back to NIST in the United States or DAX here in Germany. And all of our traceability, when we calibrate our machines, back to DAX, back to those international standards. So you can have traceability in that standpoint as well. And we also calibrate our machines to a ISO standard, which is wide open, transparent, and global. So we get kind of traceability on all levels. Our hardware is traceable to the golden parts, global, DAX or NIST. Our standards that we calibrate to are to global transparent standards. So if you have to tell FDA what you calibrate to, you can very transparently open up the ISO 10360-7 and you can show FDA how exactly you are calibrated. And then, of course, your digital results are archived. Your results are archived digitally via PyWeb. So you have traceability at every facet of your solution. It's extremely important in today's fast world that you have the confidence to push through. So, traceability is huge for us, and we've got you covered through the design at all facets with this machine.
Jay, that takes me on to my next section absolutely perfectly. It leads us into it perfectly. Now, in a day and age where technologies such as Industry 4.0, working remotely, as you've just mentioned, artificial intelligence, automation, automated metrology, the complete process really, these are new technologies that everybody needs to start looking to embrace. Would you agree?
Oh, absolutely. I think you touched on it earlier. I want to take, you know, us in our industry, you and I, we have a tendency to use these big buzzwords, Industry 4.0 automation. Um, but I like to humanize all of that and say what it means to me. You touched on it earlier, another way also, that we're asked to do many things that we never were asked to do. Um, your viewer and your listener, Geo, is likely I can imagine a machinist who might also now have to do their own measurement, right? Way back when, the machinist could just give the part to a metrologist and have it measured for them. Today, they have to do it themselves. The bridge between that is automation. Today, when we say automation, we might dream of robots, but the reality is all of those processes that we've done to make it easier, that's all automation, right? Before, we used to have to take a caliper and put it on a machine, measure a part. Today, that's automated by putting that same part down on an ODetect, for example, pressing a button and letting the machine dance around the part and getting a number. That's all automation. And what we're doing as automators is simplifying the process, because today we're asked to do more. I'll humanize it in another way. I am a mechanical engineer by undergraduate, but I got my master's in MBA. Think about it now, Gio. You're also an engineer. Today, as engineers, we're asked to have a business acumen. And we were never asked to, a generation ago, engineers were never really, we never really needed to care about cost of goods sold or things that were really business topics. Today, we're asked to do things that we were never asked to do. And an engineer now being asked to have a business acumen, these are all things that are encompassed in Industry 4.0, right? A smarter factory, smarter design, more efficiency. Efficiency is bore from the need to make things better and faster. As engineers, our adherence to an Industry 4.0, which is really a standard of making things more efficient, it's because we as engineers are asked to do more than just care if we make this within 2.4 microns. We need to care if we can make it within 2.4 microns for less than 50 cents, right? We never had to care about that. So I think when we use all of these buzzwords to make them human, is a machinist never had to measure their own parts, and an engineer never had to care about business. Today, via vehicles like automation and Industry 4.0 and adherence to that, we are doing way more than a generation ago ever dreamed we would have to do as engineers and as machinists and things like that. And it is through the buzzwords of automation industry 4.0 that we achieve that. Sorry to go esoteric on you.
No, Jay, I think no, Jay, absolutely fantastic points, and I love the way in which you do humanise them, because it wasn't so long ago that people used to use the words Industry 4.0, but they didn't even know themselves what it actually meant. And Industry 4.0 effectively has been with us for a very long time, but we just didn't realise. In regards to time, completely agree as well. I think that time is the most precious commodity that we all have, whether that's in work or in our personal lives. And I think that we all have got to be as efficient as we possibly can. And I love the way in which you explained how automation is in the ODetect, albeit it's not a robot putting the part on and off, but it's still automated in different ways. And I think that these new technologies are with us, and that they're going to be with us for the rest of our lives. And I think for the younger generation, I mean, my children, using them as an example, it seems like that they were born with them, because they just seem they seem to get it straight away. And I think that for me, the barriers to entry are maybe engineers that are maybe been in the industry a lot longer than ourselves, Jay, that are used to working in a particular way, and that maybe are frightened of change, or are not really sure what to expect, or they're comfortable doing a component in a certain way. And I think that it all boils down to education. Would you agree? Is that the way to break down the barriers to entry?
I think, my head's exploding with your point there, because there's a million different directions to go with it.
Sorry, Jay.
No, it's great. I love our conversations, Gio. I think at the end of the day, change is always frightening. To push yourself past what's comfortable is something that is sometimes not human, right? I think by evolution standpoint, we are taught to be afraid of what we don't understand, right? If when we were hunters and gatherers, our bodies are meant, the frightened system was meant to protect us. If we were scared because we weren't sure if there was a tiger in the bushes, our body immediately got afraid of that, and that protected us when we were, just hunters in the field. So this fear is inherent in our DNA, to be scared of something that we don't understand. And I think you're spot on, Gio. The way we rise above that human response of fear of what we don't understand is education. And it takes a very brave person to choose to push past their fear by education. Because automation, let's just pick on one thing. Automation isn't scary if you begin to understand what it's doing, right? I think we're inherently afraid. I know some of the images that I conjure in my head when I think of automation is robots taking my job, right? That's the classic example of it. But that's not what it is, right? What automation is doing is making my job so easier. I can do more. And if I didn't have this automation, I couldn't do more. And if I couldn't do more, Gio, then the whole business might go out of business. My whole company might go out of business because we can't compete anymore. So the way, the way you get past the fear of an automation is you really have to understand, you have to at least come to the fact that automation isn't trying to steal my job. And then when you start to look at how automation is helping me do my job, you'll find that it's not so scary. I think you and I talked about it earlier, kind of off off the record, so to speak. That's part of what the Measuring Hero vlogs that I got part of were about. The Measuring Hero vlogs were basically just me being a nerd talking about tech, and trying to do it in kind of an entertaining way so that anyone that listened to it might not be afraid of it anymore. I just wanted to present in 5-minute bursts something about tech so that you could learn and, like a dot scan, spend 5 minutes on a dot scan so you're not afraid of it. And you see it, you can touch it and feel it and be confident with it. If you don't know what a dot scan is, some of those older engineers that like, oh my gosh, I have to use a tactile CMM. What is this dot scan thing here that they're talking about? Forget it. I'm going to do the old way. Well, hopefully if you watch the dot scan video, you're not afraid of it. And if you're not afraid of it, maybe you'll use it. And if you use it, maybe you'll find yourself more efficient. I think you're right. Now that I catch myself saying it out loud, Gio, you're right. I think education is a way to break down the barriers of fear of the unknown.
And I think you're doing a great job, Jay. And I think for our listeners that have not watched hashtag Measuring Hero, please find Jay's video on YouTube. They're absolutely brilliant and educational. And I think we're definitely on the same journey, Jay, trying to educate. And I'm continuously learning. I don't know about you, Jay, but I'm continuously learning. Recently, I had the privilege to visit ZEISS HQ in Cambourne to review the ZEISS scanning electron microscope, or otherwise known as an SEM. Now, many may ask, what applications would you use this for in the engineering sector, including myself? I wasn't really sure. But when I went to the HQ, where they're manufactured in the UK as well, I was asking these questions, and with all these new emerging technologies, such as additive manufacturing was a perfect example. They're used to be able to check the powder, the integrity of the material before it kind of gets used. And prior to me going to Cambourne to check out the SEM, in my mind about additive manufacturing, I always had that question: how do you qualify the material? And I'd never got a solution until that day I went to Cambourne. So again, it's education. I think that if someone was looking to get into additive manufacturing and had that same kind of fear that I had prior to me going to Cambourne, that fear would have been alleviated, and there would have been the solution for them. Jay, as always, it's just been an absolute pleasure talking with you, and I hope that we can do many more of these podcasts together, make them more of a frequent thing.
Oh, Gio, I would love that. Thank you so much. Like I've said this to you, and I really mean it. It's always a pleasure to talk to, I'm going to say it, you're not going to believe it, to an intellectual like you, because I love to, I like to nerd out to the details, but I also do like to get esoteric and talk about education and Industry 4.0. And so, yeah, I also hope that we can do this on a more regular basis, because it's always a pleasure to talk to you. And thank you from the bottom of my heart for putting me on and letting your audience hear me. Be a dork.
Well, like I say, Jay, hopefully, Jay, this will be a more frequent thing. And also, we've done these podcasts remotely so far, but hopefully when things return to normal, and I'm sure that they will soon, it'd be fantastic to get you over in the UK and we actually do one together. It'd be a pleasure, Jay.
I would love that, Gio. Let's when the world pivots towards us again, let's do it for sure.
Absolutely, Jay. Well, thank you very much for your time, Jay. It's been a pleasure. I hope the listeners at home or in the gym or in the car have absolutely loved this podcast. They enjoyed this podcast and learned from this podcast. And if you've got any comments, don't hesitate to contact us to find out more. Until next week, the MTD Podcast.
Thanks for listening to the MTD Podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.